Okay, great. Welcome, Fred. Glad to have the opportunity to chat to you about the session you're going to talk about. Rather than me talking about what your background is in the different bios, I understand you've been deeply involved with IETF and a lot of the ecosystem. Can you sort of give a thumbnail sketch on what you've been up to?
Well, sure. And now I have a question. Are you going to show my slides?
Yes, they're actually recording right now.
Because this is the second slide. Yeah, you gave me a whole list of questions, and so I went through and I literally answered your questions.
Okay.
And before we get started, I need to apologize for missing Monday. I don't know how we wound up at different times, but I thought it was 2 hours later than it actually was.
You know what? I was working away on stuff this morning, and I looked and I said, "Oh, the calls for 11." I actually thought thought it was earlier on, and then it dawned on me. I'm chasing a bunch of stuff, and I go, "Oh no, it's 2 o'clock my time." So here we are. So no harm done.
Yeah.
Glad to
Okay.
have you in it. So
Yeah.
maybe talk a little bit about your background first, so people can get to know
Okay.
you.
So go forward 2 slides.
Okay, 2 more slides already. Oh, hey, great.
Yeah, you asked me to talk about myself, and well,
Yep.
okay, here's myself.
Okay.
I've been involved. I actually got involved in what you might call internet development in 1986. There was a workshop that was pulled together by Dan Lynch and maybe 300 people sitting in a room in Monterey, California. And he got various and sundry luminaries, people that started the internet, to give talks about whatever their protocol or their application was. And that none of them actually prepared slides or prepared, I'm sure they reread their stuff or whatever, but they got up and just started talking, and they produced clear acetate sheets, which they set on the projector and started madly drawing. And it was really a very interesting and very real-time session. And at the end of it, Dan got up and he said, well, did you guys find this useful? And well, yes. Next question. And so we had another one, and we had, I think it was 2 a year for 3 or 4 years. And eventually he sold the thing to Interop, or to Network World, and it became Interop plus Network World, and which is a big show that travels all over the world. But the idea of doing what it was that we, the engineers, were doing at that show was that just didn't work. So basically, we all got up and we went somewhere else. And in my case, the somewhere else was an organization that had just recently been cobbled together called the Internet Engineering Task Force, which I had an interesting experience of that. My first meeting was at Stanford, which was at the opposite end of the bridge from where I worked. And they said, oh, by the way, we're going to have a meeting in Hawaii. And so I went home and told my wife, in November, I'm going to need to go to this meeting, and I thought I should tell you because it's going to be in Hawaii. And she said, oh, are we taking the kids? And well, the answer is we have 4 kids, and we took 2 of them. 2 of them stayed with friends. And she wandered all over Honolulu, checking out things that are in Honolulu. And in my case, I sat in the basement of a building at the university there and talked about computers. And she still will talk about these crazy people. They went down in the basement, talked about computers. But okay. So that was 1989. And as far as standards and standards development, that's when I got involved. Now, a few years later, they asked me to chair the IETF, which I did for 5 years.
And how big was the IETF when it started? Like, how many members?
well, the very first meeting was, I think, 23 people.
Oh, wow.
But when I got involved, it was a couple hundred. Um, and it became quite a bit larger over time. And then in 2001, when the bubble burst, the economic bubble, well, then it became really just those people that were actually directly involved in internet standardization. And many of them no longer had companies. Their companies had gone under. So it became quite a bit smaller in the neighborhood of 1,500 to 2,000. And now you generally find about 1,000 people at a meeting, should a meeting actually occur, which is the next question. The pandemic does get in the way. But yeah, so I was the chairman there. In the course of that, we developed this thing called the Internet Society, which was a merger of two organizations. One of them was run by Larry Landweber from the University of Wisconsin. He would basically get people together to talk about, gee, there's this internet thing, and how is that going to affect government? How is it going to affect business? And realize that it has not yet affected government or business or data communications or anything. The World Wide Web has not yet been invented, and so on and so on. They and the IETF got together and said, well, what we should do is organize this into what do we call it? Let's call it the Internet Society, and have chapters in various places and organizational members, and let's make this a little bit more stable environment than it had been. And so in 2002, I believe, I became the chairman of the board of the Internet Society, and I was on the board for 6 years. I was its chairman for 4. In the course of time, I've chaired a number of working groups, and right now, for perhaps the last 10 years, I've chaired IPv6 operations with Ron Bonica or Joel Yeagley or several co-chairs. But right now it's IPv6 operations with Ron Bonica from Juniper. And in the course of that, I became a member of the board of the Internet Software Consortium, which runs FRoot, one of the roots of the DNS service. And they needed somebody to go to ICANN meetings and get involved in the root service at ICANN, which I did. And eventually they needed a chair, and I became the chair of the root server system advisory committee in ICANN. So I'm that. And I've been asked to be a lead engineer in an ITU focus group working on quantum technologies for networking. So what am I doing right now? Well, it seems like a lot of what I do is chair things.
Yeah, but that's a talent in itself. You've shown you've been a chair for, gosh, looks like what, over 20 years in different capacities.
Different capacities, yeah. And at the moment, I'm chairing 3 different things at once. So, which one of the interesting parts is having them not trip over each other. Let's have meetings at the same time, and I'm chairing both of them. That question comes up, and I kind of have to say no, and that kind of thing. But okay, that's me. That's what I've been doing. I've written a lot of code, mostly for Cisco Systems, which I worked for 22 years, and I'm a software engineer. That's what I do. But right now, what I'm doing a lot is I'm semi-retired and I'm chairing working groups. So that's me. Next slide, please.
Maybe I can ask you if you look at the ICANN's strategic plan, in the last couple of years, DNS abuse has become much more of a central theme. and you see the DNS Abuse Institute created and supported by PIR, and where do you see the RSAC moving in terms of its advice back to ICANN? Is that becoming,
Well,
as I said, is it becoming more of a hotspot for ICANN?
well, DNS abuse is, it seems like every group has their own definition of it.
Sure, yeah.
Does this mean that somebody is getting names and then sitting on them, hoping to sell them? Does it mean that somebody is getting names which they will then use to promulgate services that we would wish went somewhere else? Does this mean that they're a country which wants to have its own root? And there are several of those. I mean, there's a lot of stuff going on, a lot of discussion in ICANN. At the last meeting, which was a virtual meeting, we actually had, I think, 3 or 4 different sessions on DNS abuse, each from a different perspective and with a different definition of the problem. And so what's the RSAC doing with that? Well, let me explain to you a little bit about what the root server system is. You can think of there being a process of names going through the system. Somebody makes a proposal to ICANN. The ICANN board decides that, we'll go with this one. And they ask for the name to be put into the into the IANA database. And then that organization, whatever organization it is, and I mean, there's a long list of them. There's, I think, 1,530 names in the root system right now, including the country code domains, but okay, a lot of names. So those operators, the registries and the registrars basically bless an operator, and they become a TLD, a top level domain operator. And they work with ICANN to make sure that the right name with the right information goes into the IANA database. Now, then there's a contractor. The current contractor happens to be from VeriSign. There's nothing that requires it to be from VeriSign that I know of, but that's where it's from. No, that's where Dwayne is from. And they take that information, which is in the IANA database, and run it through a process, and it becomes a series of resource records in DNS, which are now posted, and the different root server operators will download that file or that set of files to their various systems. And I'm told that there's about 1,350 root server instances worldwide. The thing that is important about that is that they all have exactly the same data. You can ask the same question of any of them and you will get the same answer. And why is that important? Well, let me explain it with an illustration. Suppose that I asked you I asked a random person on the street how to go to the corner store. And they each had a different notion of which corner that might be on and which store that might be. And so I'd get that many different explanations of how to get to the corner store. Well, that wouldn't serve the store. That would serve a person that wanted to find, flour or something like that. But if the store is trying to offer a service, that doesn't serve them. One of the important things in the internet has been what we call the end-to-end principle. And the end-to-end principle basically says that the internet should be predictable, that if some actor, some person, some computer originates a request and sends it somewhere, it should go to that somewhere, and it shouldn't go somewhere else, and it should be interpreted uniformly. Well, so what we're trying to do is provide a way to implement that on a global basis. Whether you're in Spain or whether you're in the US or whether you're in Bolivia, if you want to know how to get to example.com, you should get to the same place. And now that service might have several instances that are in different places, and that's fine, but you should get to an instance of whatever it was that you asked about. So we have, it turns out now, 12 different companies offering actually 13 different root services. VeriSign bought one at some point, so they operate A&J, but the rest of us just have one letter. And together we offer a service, which is the distribution of names from the IANA database to whoever asks for them, which would typically be resolvers. So then people ask a resolver, how do I get to example.com? And the resolver says, here's the resource record for that. And that's predictable basically because everybody has the same information. So what does the root server system think about DNS abuse? Well, what's your definition? If your definition is that names like how to do bad stuff.xxx should be accessible, and different people have different views on that, but the XXX is actually in the root server system. And so we deliver everything that IANA puts in its database. The database is developed by the ICANN board or by decisions from the ICANN board. And so, we get that from the root zone maintainer and we deliver it to whoever asks. And the one thing that we would really, as root server operators, would want is for that process, that transactional process, to be clear. And so a lot of what is under discussion in DNS abuse is actually not our problem. And so we don't really have an opinion on it. Okay. That said, please don't screw it up. I think that's the big thing that we would ask.
Okay, well, that helps a lot because I think I need to read up more, and maybe are the RSAC meetings open to the public, or is it strictly membership only?
Well, that depends. We have meetings and we have meetings. The ICANN meetings, the meetings that happen at ICANN are all open, okay, which is to say that people are allowed to be observers. We welcome them into the room. We may or may not recognize them to speak, but they're allowed to be in the room, listen to them. The members of RSAC are defined by the ICANN bylaws, and they are representatives from the root server operators. Okay. There are people that would like to see that changed. Specifically in 2014, and then I think in 2018 or 2019, there was ICANN requires there to be reviews of the different organizations in ICANN, and there was such a review of RSAC in those 2 years, and in both cases they said we'd really like there to be allowed to be people that are not root server operators. And well, that's determined by the bylaws. If you want to see that changed, change the bylaws. As it stands, we're a bunch of people that are working together to offer a service, and basically trying to not screw it up. What we have done is we've created something called the RSAC Caucus, which is a set of people, self-selected people, that have some expertise related to DNS and some opinions about RSAC. And we look to them for whatever expertise that they might offer. They are not root server operators. They are often resolver operators. They may work for ICANN. There's a list of places that they come from, but these are people that want to improve the root server system, and I have opinions on that.
Okay, well, you know what? I'll add the links into the YouTube because of the recording. I'll add the links to the RSAC group as well as the RSAC caucus. So shall I move on to the next slide?
Yeah, sure.
Okay,
So you
Yes,
asked, who are the actors in the internet governance ecosystem? And well, they fall broadly into two categories. And of course, my first problem is the term internet governance. It's very widely used. To me, governance has something to do with government. Somebody might say, this is a good thing, this is a bad thing.
Sure.
And it's not that. What it is, if anything, is the development of standards, agreements for the operation of different things, protocols, so on and so forth. And they fall in two general categories, governmental systems and systems that aren't. The intergovernmental systems originated with the telegraph, and basically once upon a time, getting the right of way to drag wires over farms or whatever there might be, and then interconnecting sovereign countries using whatever was going over those wires. That was a really big deal, and the governments were the only ones that had the money and the power to make those things happen. So the governments got very deeply involved in communications. And one of the outcomes of that was the development of the International Telecommunication Union, which came into being by that name in, I think, 1969, but it has progenitors going back to the early 1800s. And they're involved in, what frequencies will you use for radio, and how will you do various protocols and so on and so forth. And they're centered in Geneva.
So that you're bringing up something it also puzzled me. Why was ITU asleep at the switch? It always reminds me when Bill Gates was asked about the internet, he sort of, nobody needed anything more than 64K. Were they not aware at the time that this was an emerging technology, that or was it sort of outside their bailiwick?
Well, it was in a sense outside their bailiwick. They considered the development of protocols that would run on top of wires to be the province of the International Standards Organization, ISO, which is one of those intergovernmental organizations. And there was actually a development of such a standard in ISO, the Open System Interconnector Reference Model and the associated standards. And now the internet grew out of a research project, and understand that you generally don't want to standardize something that hasn't been developed yet. You would like to prove that it works, and then say, okay, there's 5 different ways we could do that. Let's do this one. And so a standard is essentially that kind of an agreement. And there were a variety of different networks that were being developed, which had different models. There was Cyclade in France. There was, I forget, a long list of different projects where basically educational projects, or in some cases, a company starting to develop a product that it wanted to sell as a proprietary protocol. And there was no agreement. In the U.S., the experiment that was being developed was the ARPANET, and then that was sort of taken over by NSF. So it became the NSF-net in the early to mid 1980s. And of course, there were DECnet and IBM SNA, which means still not available, and a variety of different things that people were working on. So, what did the ITU think about that? As well, there's so many of them that maybe one of them will emerge as important, and then we will take that over. And that was kind of their attitude. And well, by the way, everybody didn't want them to take over. And so in the early 1990s, the issue really became one of the different operators of corporate networks who sat down with their vendors and said, listen, there's this thing called IP. It runs over that network over there, NSFnet, ARPANET, whatever, that network. And your application, Novell NetWare being a very important one, your application is just fine. We use it all the time. We probably something we want to tweak, but your protocol is hard for us to work with. And would you please make your thing, whatever it is, be able to run over that internet thing over there? And otherwise, we'll stop buying your product. And well, when you say we'll stop buying your product, the companies will sit up and listen. And so in the, 1993, 1995 timeframe, basically all of the companies that were doing this recognized that there was no future in their proprietary, whatever it was. They continued to sell that, but they added the option of running it over IP, and lo and behold, in a very short time, it was running over the internet.
Was that an open standard at that time?
Well, internet standards have always been open.
Okay.
And some would argue that they define being open. Open means that somebody can read it. Needs to be a published standard that people can go read. And in many organizations, it's open to their members. And you might pay a lot of money to be a member, and then whatever. Or you can buy copies of the standard, and that funds the standards development organization. There are several organizations of that general category. But in the IETF, we made the documents available kind of to anybody that asked. When the web came into existence, we put them on the web. You want the document, you go download it. And that's way more open than an organization that says, sure, you send us $1,000 and we'll send you a stack of paper. Which a number of the governmental organizations were of that general category. So yeah, the IETF has been open for all the way along. So, okay, there's the governmental organizations, and then there's individuals and organizations, the IETF being an example. The Internet Architecture Board was, at least at one time, essentially the researchers that started what we now know of as the Internet, and has evolved in time to kind of a think tank trying to figure out what's next. In 1986, the IAB took several of its activities and declared them to be task forces. And well, the task forces mostly related to research, and those research task forces merged together to become the Internet Research Task Force, and are now research groups within the IRTF. So you can go look at that. People have a little bit of a hard time distinguishing between the IETF and the IRTF because they both produce internet drafts and eventually RFCs. But the IRTF doesn't produce standards. You have to get somebody more than the researcher to get involved in
So
order
all
to.
the RFCs are through the IETF then?
All of the RFCs are through the RFC editor, which is an
Okay.
office that is funded through the IETF.
Yeah.
And the IETF, so there's different streams that what are called streams that feed into the RFC editor's office. The IETF is the largest one by far.
Mhm.
The IRTF is one of the IAB has their own stream.
Oh, okay.
And there's an independent stream. If you can't get yourself heard in some other way, then you can go to the independent stream editor and say, I'd really like you to take a look at my document, whatever that is, and proceed from there. So the RFCs are produced by the RFC editor with those streams as feeding into them. And then, of course, there's the IEEE, there's the W3C. They don't produce RFCs or whatever. They are separate organizations and have their own way of doing things. And that's not wrong. It's just they're different. So, and I've given you a list of organizations here. It's in no sense exhaustive.
No.
There's quite a few other organizations, but these are the ones that people will probably recognize.
Just on the back to the ITU, I don't have a fetish with them, but given the fact that more and more people are using their mobiles for internet access, and whether it's M-Money or identity or many of the features. So are we going full circle that many of the standards that were created for Spectrum for telcos, do you think the ITU is more of a bigger player as looking at this ecosystem? So do you think with the emergent of the last billion people that are coming online, and they're never in front of a computer, strictly it's all through the mobile?
Well, the ITU is certainly an important player in what it primarily develops is, if I think in terms of the OSI stack, they develop technologies for allowing point A to talk to point B, perhaps using radio, perhaps using fiber or whatever.
Right.
And then they allow other protocols to run over the top of that in order to accomplish things. And so, for example, if I go to 3GPP, which is a project of ETSI, ETSI is using IETF protocols running over ITU interconnects in order to accomplish its network. And it's interesting watching the statements people make about that. ETSI would tell you that mobile is taking over the world. The ITU will tell you that 80 or 90% of the world's communications cross ITU-defined channels. And it's just kind of interesting. Everybody seems to have a way of saying, and we're the big guns.
Shall I move to the next slide?
Yeah, sure. Okay, now you asked what the interface between the technical and non-technical communities was. And there's more than one, but certainly Larry Landweber's interconnect workshops in the 1980s were an important part of that. And that, they emerged with the IETF in order to develop the Internet Society. The Internet Society was developed in part to allow non-techies and techies to talk to each other and enable communication between those communities. I would say that remains imperfect, and there are a lot of glitches in that. There's one that's happening right now. The European Union is developing, or the European Commission is developing a legal framework which it calls NIS2. And one of the things that it's decided that it needs to do is regulate the internet route. Well, so think about who are the organizations that are the internet route, or that operate the internet route. There's an organization in Stockholm, there's an organization in Amsterdam that each operate one of the route services. There's also the United States Army. Operates a route service. The United States Defense Information Systems Agency operates a route service. NASA operates a route service. And there's a number of NGOs, there are a number of non-governmental organizations, nonprofit organizations, ISC, the company that I'm on the board of, being one of them. And so, okay, if European Commission wants to regulate the internet route, who are they regulating? And they might be making threats against people with atom bombs, and they might want to think about that. Sure. So for the most part, this presents we're going to provide a uniform service. We're going to make everything work for people that want to use it. Under the covers, there can be a fair amount of pushing and pulling about, so how do we actually do that? So the ITU came up with WSIS, which has dominated the language of internet governance, the concept of a multi and I'm drawing a blank on the actual word. It's probably on the next slide. What's the next slide?
Okay. Yeah, I attended the WSIS in 2003 in Geneva. That was the first one. I didn't go to Tunisia, but I was at the first one.
Yeah. So
standards.
Okay, no, that isn't the one that I was thinking of, but okay. So back up a bit. Okay, so go back one slide.
Okay.
So one of the important things there was we've got governmental actors, we've got non-governmental actors, and the governments for a long time thought that they ran everything, and kind of business operating on the fringes around the governmental actors develop things in such a way that they could mostly ignore the regulations and the regulators, but simply go ahead and make things happen. And of course, there's the different communities of engineers that are doing things, and people that we're thinking about, so what's the impact on my country or my people, and how does this energize blind people? How do I get networks into the mountains of the Himalayas? And so one of the important things in WSIS was the recognition that not all of the important actors represented governments. And that was, there are governments that are still reverberating with that one. That's certainly what's going on in Russia and China right now, where the government is saying, no, we run things. And life, the business community is kind of saying, well, you don't actually operate a network. So, we need to talk. So that interface has been a contested one. It's not necessarily obvious how things work, but we try to get everybody to talk to each other. So, okay, now next slide. Okay. You asked why standards are relevant. Well, Standards are relevant in all kinds of places. You think about the size of a paper. You say, I want a piece of paper that I would write a letter on. In Europe, that piece of paper that you would write a letter on is defined by a standard called A4. And it's a certain length, and it's a certain width, and it's a certain weight of paper. And having a standard allows somebody to go make that paper, put it in a store, sell it, and then other people to build copiers that actually use that paper, turn into whatever. It turns out that the size of a piece of paper is a relatively important standard. Vehicular dimensions are regulated. If I put a bunch of cars on the road and some of them are cranes that would be 5 times the width of the road, that actually, that's not a good thing. You want cars to be typically about a certain size so that they'll fit in a lane, so that they'll sit in a parking space, so that various things about the size of a car are important. And so there's a standard that says cars should be this size. Contact lenses. My sister-in-law who is now retired, used to work for a company that made contact lenses, and she was the person who talked with the FDA for that company. They are they don't go in your body, they go on your body, but the Food and Drug Administration has regulations about contact lenses, and it's considered a prescription medical device. So there are standards related to contact lenses. In communications worldwide, the telephone was heavily regulated. Why was it heavily regulated? Well, the governments built the first networks. And the internet came in alongside and used those networks, but did something different with them. And so, at least in the United States, the telephone system was heavily regulated, but the thing that ran over the top was essentially free of regulation. And that was something that the FCC thought was a good thing. And now people are getting excited and kind of driving toward a little bit more regulation in internet type development. And as I've mentioned, there are certain countries in the BRIC category that are looking for quite a bit more regulation on the internet. So next slide. Which actor is important? Well, and you asked me, how do we provide a consensus among these different organizations that govern communication, or develop standards for communication? And the answer is that we really don't. What we do is we kind of recognize the expertise of different organizations, and so ETSI developed a specification, several specifications for how to run mobile networks, and kind of the rest of us have said, they're very good at that, we aren't. Let's let them do that. So the different organizations each have their expertise, and we generally try to not trip over each other, and we do occasionally trip over each other, but we try to minimize that. Which one's important? Well, it depends a whole lot on what question you're asking. And okay, next slide. The multi-stakeholder model, that was the word that I was trying to remember and escaped my mind a little bit earlier. Multi-stakeholder model. What is it? Well, and WSIS is the people that came up with the word. In fact, the internet had been using it for about 20 years at that point. In that context, the stakeholders were specifically government, industry, and civil society. It turns out that many of the organizations that develop themselves using a multi-stakeholder model would define who the actors are in different ways. And they're not necessarily those. One of those will be government. One of those will be some variation on industry. In the IETF, the operators tend to distinguish themselves from the vendors, and sometimes they'll have spats between them. Is, you know, they're terrible. They're just vendors. But the key thing there is that they get together, they talk about things, and they perhaps negotiate hard, and eventually come to an agreement about how some service should be deployed, and in order to meet the needs of each of the different actors. The word stakeholder is interesting in that context. It originates, I understand, from horse racing. If you go to a track and somebody's going to run a race, well, the first thing that happens is that a whole bunch of people run down to somewhere and they say, I think horse number 12 will win. And they put some money down, which, you know, eventually gets divided up and handed back to them, or hopefully gets handed back to them. The money is referred to as a stake. And the guy who acts as the escrow agent to distribute that, to manage that, is called a stakeholder. You know, so that's actually where the word came from. Now, the way we're using it in the communication world tends to mean, well, yeah, ICANN has a definition. ICANN's definition is that X is a stakeholder of Y if and only if the actions of Y affect X. And so X gets the opportunity to make a comment about it. It can be, in the RSAC, we're in the process of evolving the organization of the root server system. And one of the questions was, who are the stakeholders of the root server system? And well, there are a number of different ideas. Certainly any user of the internet, which is quite a few people, are affected by the what's in the root. And so from the definition that ICANN gives, in that sense, we're all stakeholders. What we, in writing that document and in trying to discuss it, what we've generally talked about more is who would make decisions about the root server system, where would the money come from, and that kind of thing. So we've kind of narrowed that down to the Internet Architecture Board, representing the standards organization developing the standards for DNS, and the ICANN community, which is quite a few people. It includes the top level domains, it includes the governmental actors, it includes, you know, quite a few people. So ICANN as a community is a stakeholder, and you could divide up ICANN into different stakeholder groups among it, but they're all there. But the key thing about the multi-stakeholder model is that you get people that have a usually business reason, a reason to be involved in something, and get them all to talk about, well, what I need out of whatever this is, I need this, and try to figure out a way, which involves quite often a lot of baseball, figure out a mechanism that actually meets all of their needs, or meets enough of their needs that they're willing to go with it. Now, next slide, you asked me to talk a little bit about the IETF, which I have some, I know who they are. So I describe the IETF as a loosely knit organization of volunteers. I usually refer to it as a disorganization.
Mm.
Um, but it is a set of people that write RFCs. Now, where those people come from, some of them come from vendors, some of them come from regulators, some they come from education and research. They come from basically all walks. But in the IETF, we really didn't want to get into the game of, okay, so you're a regulator, so you're important here and you're not important there. Or, you're in this category and therefore this aspect of your opinion is important. What we wanted to do was provide the ability for anybody to be able to comment on anything and push things in a direction that they needed them to go. So what we have said is we're going to completely ignore the existence of governments, the existence of companies, the existence of quite a few things that people would consider obvious. We are a bunch of people, and where we come from and what sets of opinions we bring, we deal with that. And sometimes we'll get companies. I'm thinking actually of a particular meeting where Sun Microsystems sent a large group of people to go sit in a room and vote yes. And when that meeting happened, we said, okay, so this entire group of you, we know that you're from that company and that you have sent for this purpose. And so I'm going to consider you as if you are one actor.
Wow.
And the thing that they were sent to vote in favor of actually failed. And why did it fail? Because what we were trying to do was not push to the benefit of a particular company or a particular person, but for the internet. And what is going to work well for the internet? Well, we decided that that particular technology didn't serve the internet well enough. And so we went to a different technology. We think in terms of these being people, and sometimes we have to deal with the fact that they come in clusters and do something about that. But we'll do that in an open discussion and get everybody to kind of agree on how the outcome will be produced. So what do we do with that? Well, we divide work into areas. And I list the areas there are the current ones. They've changed from time to time. And then work is accomplished by working groups, which come into existence and go away from time to time. If you want to track all of that information, I put a link to the data tracker there, and the data tracker actually has all that information. It's reasonably well named. So moving ahead a slide. You asked what the role of the IETF was with regard to the internet infrastructure. Well, RSAC 37 is the document which is proposing a governance model for the DNS root server system. And this is an actual sentence out of it. It says the IETF defines the technical operation of the DNS protocol. So the RSAC does not tell the IETF, there needs to be this thing, and the IETF provides a protocol. That said, operators from the people that work for operators from the root server system are involved in the IETF, and if they need a problem solved, they go to the IETF and as part of the IETF solve it, whatever that might be. Interdomain routing, as defined by the IETF, is how every company on the planet talks to the network and ultimately to each other in terms of routing. So if you go look at the writings of those different activities, whatever they are, they will tell you what specifications they use. and some of them are from the IETF. Okay, now moving ahead a slide. I pick an example in terms of encryption. In the United States, the Federal Financial Institutions Examination Council is a government organization that tries to make banking regular enough for people to understand and financially stable and so on and so forth. One of the statements that that organization makes is that they should employ encryption to mitigate the risk of disclosure or alteration of sensitive information in storage and transit. And I think of that statement when I hear people like the Attorney General of the United States making statements that, well, we need to have back doors that allow law enforcement to break encryption.
Yeah.
And well, okay, as soon as a backdoor exists, who is the first person that's going to use it? It's going to be organized crime.
That's right. Yeah.
Which is why the IETF and other organizations have pushed back actually pretty hard on law enforcement worldwide to say, no, we're not doing that.
Yeah.
And because the objective is to mitigate the risk of disclosure or alteration of sensitive information in storage and transit. In the words of the United States federal government. What do they use? Well, they use NIST has an encryption standard, which what does NIST stand for? National Institute of Science and Technology is an organization which does research and pushes to make sure that the communication specifications exist that serve the needs of industry in the United States and the United States government. One of the things that they've come up with is an encryption standard, which is in use worldwide. And then that standard can be used by the web. Web protocols are developed in the IETF. The data that is carried in the web is designed and standardized by W3C. But so HTTPS and TLS, transport layer security, use, among other things, NIST protocols, and allow then for companies, people, to communicate in a hopefully secure fashion. One of the things that we found, next slide, one of the things that we found ourselves looking at is in 1990, the IETF had a meeting which, by accident, actually happened at the University of British Columbia in Vancouver, Canada. It was the first time that we had a meeting outside the United States. And there was a statistician by the name of Frank Selensky, who stood up at that meeting and gave kind of a very quick talk in which he said, you know, I've been watching the way you hand out IP addresses, and you might want to think about that, because if you continue where you're going to run out of IPv4 address space by 1994. Mm-hmm. And you know, the rest of us sitting there listening to him said, that would be a bad thing. Let's not do that. And so we immediately went and did a number of things. One of the things was that the IETF put out a request for people to provide alternatives as a next generation protocol. And it wasn't because the new protocol should not be backward compatible with IPv4, it was because the IPv4 wasn't forward compatible with anything. And, you know, so what are we going to do next? And one of the questions that came up, there was a research experiment that was done, which became pretty popular, which became something called network address translation. If you have been anywhere near the internet, you have used network address translation. And that has its good points and its bad points. and there's been a number of different things that have happened in that direction. But as business grew and needed to use the internet, it became pretty obvious that we needed a new protocol in order to have a new address space that would allow business to do what it did. And that became IP version 6. Now, IP version 6 has been in the process of deployment since 1998. Meanwhile, there's a lot of people that have pushed back pretty hard and kind of said, but, why can't I continue to use IPv4 in some category? So I'm showing you two graphs here. One of them is put out by APNIC and is a measure of how many addresses are available from different regional internet registries. And figure it any way you want to figure it. Bottom line, there's not much IPv4 address space available. There are some people who had early grants or bought a lot earlier or something like that and are now selling their address space. So the picture on the right is from an organization which, if addresses were real estate, would be a real estate agent, connects a buyer with a seller and allows for the transfer of addresses. And what they're looking at is, what is the price of an IPv4 address? And well, over the last 10 years, that price has gone up fairly dramatically.
Wow.
And this graphic, I think, actually came from 2019. And price is now higher. And that winds up being the very best argument for a next generation protocol at this point. So, one of the things that the IETF has tried to address is this fact of IP address space running out. And, I chair a working group in the operational space of that. So next slide. One of the comments that people make about IP version 6, and here I'm quoting from an article that I read somewhere, IPv6 is actually not being deployed. And well, gee, it sure is effective for something that isn't out there. You can go to a number of different places. The places I tend to go to are Google, APNIC, and Akamai, but there's other people that measure use of their systems by IPv6 and make those numbers available. And as of whenever I made these slides, which is a month ago, 80 countries where you could look at the traffic that is coming out of their country, and at least 5% of the traffic is IPv6. And in the case of perhaps 20 countries, it's half or more than half of the traffic that comes out of that country. India is actually huge, and particularly one operator in India. But Belgium is huge, Malaysia is huge, Germany is huge, Taiwan is huge. There are a number of those countries where IPv6 has become very important, and there becomes a question of, why don't you just turn IPv4 off, which they will eventually do. Okay, so this is the last slide. And you asked me, how do you get involved in the IETF? Well, you probably start out by reading an RFC or an internet draft. And if there's something you don't like, you probably join a mailing list and you watch the conversations that are going on. If the conversation you care about isn't happening, you send an email and start the conversation, and it is what it is. So if you go to those various links, you can figure out how to join a mailing list for a conversation that's important to you. Sooner or later, you're probably going to want to do something a little bit more than send an email. And our way of doing that is to write what in the ITU is called a contribution. You write an internet draft. An internet draft is basically a prototype of a well, it's a statement. It might be literally a white paper. There's a paper that RFC 990 was. The title of that document is hang on a second.
You were mentioning about how India has been one of the pathfinders on adoption of IPv6, but I think speaking of RFCs, I think there's been a big campaign also in the universities and throughout India to get more people involved in participating with the IETFs and especially with generation of RFCs.
There has, and so I found myself in Calcutta not too long ago, trying to help them accomplish that. And okay, I found the specification I'm thinking of, which is not a specification; it's a white paper. It's RFC 970, and the title of it is on packet switches with infinite storage. Mm-hmm. Now, in the 1980s, one of the things that we kind of wrung our hands and said, something should happen here. And, wouldn't it be nice if we could afford to put more memory in computers so that we can do interesting things? This is the era in which Bill Gates said 640K is enough. Yeah. And well, if I look at the Mac that I'm looking at right now, it has 4 gigabytes of memory, and it's considered small. You can buy computers with quite a bit more memory in them, and move forward. So John Nagel, who at the time was an engineer at Philco Ford, was thinking about this and said, okay, what's the next step? Let's imagine that I can create a computer that has infinite storage. What's the next problem I'm going to run into? And the next problem that he ran into pretty quickly was a bug, truth be told, in the TTL field of an IPv4 header, which said that in order to have packets that get lost, just not be roaming around forever, you eventually want to flush them out of the system. And the original specification said that should be a matter of time, that time to live field, named time to live, was a measure of seconds. And well, if you do that, and if you follow the specification quite literally, then you could wind up with a system where queues become very deep, and a packet can arrive at a queue and be perfectly legitimate, get to the other side of the link and be discarded because it is timed out. And so you wind up with 100% utilization and 0 throughput, which is not good. And so he made a proposal, said you could solve the problem this way. And there wound up being a huge amount of discussion in the research community and among the vendors, and I was involved in that, to figure out, what are ways that you can solve that problem. And so that problem actually occurred in the NSFnet in 1987. And we had congestive collapse in the NSFnet. Okay, so you write a document, which might be like this one, might be a white paper, it might be a specification. This is the way you describe an HTTP packet. This is how you have that conversation. You maybe you don't like TCP, and so you want to go work on Quick, and so here's how Quick might work, and, that kind of a thing. So somewhere along the way, you'll probably wind up wanting to write an internet draft, which is a discussion paper, and you'll get involved with then discussion of that thing. People will say, well, that doesn't work for my case because of this. Okay, so let's talk about that. How do we fix that? And maybe you decide that your idea was a bad idea, or maybe you say, well, gee, we can address your problem and my problem if we change these words to those words, and so on and so forth. That conversation, that group conversation, is kind of what the IETF is all about. And ultimately, what pops out of that is something that everybody mostly agrees to. And I want to be careful in saying not everybody agrees to. That would be the Iroquois democracy, where we don't do anything unless literally everybody agrees. Well, everybody's a lot of people. And so what we've wound up is something that we call rough consensus, which is most of the people agree with most of something. They can live with the part that they don't really agree with. And what's important then, we find as a general rule, the majority is wrong, the minority is right. The minority has some observation that actually needs to be understood and dealt with. And so we categorically listen to the minority and try to address their issues, whatever they might be. There is, of course, the case in which somebody just absolutely refuses to back down, and eventually we say that person's in the rough, and that is not going to be the way we go forward. But for the most part, people can find ways to, I can agree with this much and I can live with the rest. And that is what becomes the standard. A comment that I've heard made is that you continue talking about specification until everybody's equally unhappy.
Yeah.
Okay. So, I mean, in the IETF, it's ultimately about mailing lists and about documents. You can get some help, and quite often people will get involved in kind of, I have no idea what to do next, help. And you get somebody who's been around 5 minutes longer and work through things. I wind up mentoring people. There's a lot of people that do that. And we have meetings from time to time, and you can go attend a meeting, and it's often a good way to meet people, to talk with whoever it is that's pushing some idea that you have a problem with, and sort out the issues then of communications. So there are some resources there on the links, and I think you're distributing these slides, which is fine.
Yes.
And so people are welcome to then use those links and get involved. Okay, so now at this point, I've been yammering for a little over an hour. Do you have questions for me? How do we?
This, especially this last slide, I think is so imperative. And I guess the straight question right off the bat, can you participate remotely if you don't have the funds to go to an IETF meeting? And if you can participate remotely, is there a cost for attending any of the remote meetings?
Yes, you can participate. As a matter of fact, with the pandemic, all meetings are remote. And so it's the only way we do it. And what we have been forced to come up with, you pay an attendance fee to show up physically at a meeting. And what does the attendance fee do? Well, it basically pays for the infrastructure of the IETF, the fact of somebody running the internet draft directory, and so on. So you wind up covering the costs in that way. With remote attendance in the pandemic, we found it necessary to charge a fee, which I think is $230, to attend a meeting remotely. And literally what we're trying to do in that is cover the costs of running the internet draft directory, operating the RFC editor's office, and that kind of thing. So yes, absolutely, you can join remotely. And I guess I didn't put a link there, but if you go to the IETF webpage, ietf.org, in a banner across the top of it, it will say, by the way, we're having a meeting. The next meeting is theoretically in San Francisco. Of course, it won't really be there, but we're pretending it's there. And click on this and you can register and get involved, and so on and so forth. So yes, there are remote meetings. We use a service called MeetEcho to operate those meetings. And for the last year, I have everything that I've done in the IETF has been remote. And yes, there is a cost, basically, because we have infrastructure that has to somehow get paid for.
Is there a fellowship for people who are coming from least developed countries, so they actually can access these meetings and be subsidized?
Well, I think there are some stuff for least developed countries. There is specifically a subsidy for students. If you are a student at an academic institution, you can. It costs a lot less. I don't remember the exact number, but it costs less. When it comes to least developed countries, we have less people from those countries. We do have people involved from Mauritius and from other countries that in various places, and we haven't specifically tried to reach out to them to try to cover their costs. The Internet Society has done some of that. There are other folks that have tried to do some of that, but at this point, we have enough people coming from those countries that it hasn't become a priority for the IETF itself.
Yeah, since the IETF has spun off from ISOC and have their own organization and their own budgets and stuff, has many things changed with them in the last couple of years?
At this point, actually, there have been no changes that I'm aware of. Okay. We have an LLC, and we talk with people. We talk with different people about money. And the Internet Society still contributes actually pretty heavily to the operation of the IETF, but no, we haven't fundamentally changed anything. It's not like we're charging for access to an RFC or that kind of a thing.
Okay. How does someone get in touch with you, Fred, if they want to make a connection? Perhaps you might be interested in participating with one of their conferences they're doing, or just to actually ask a question or reach out to you.
Well, I probably should have written down my email address in somewhere in this slide deck, and I didn't. But my email address is fredbaker.ietf@gmail.com, and people are free to send me an email, and we can discuss whatever whatever they want. That that has happened in the past, and actually has been pretty interesting. I once got an email from a high school student in Delhi who basically said, my teacher gave me this, gave the class this assignment, and I have no idea where to start or where to look. Could could you mentor me? And so I had a short email exchange with a high school student. That happens, and that's normal. I'm on LinkedIn. Look up Fred Baker on LinkedIn. You'll find me. So I used to be on Facebook, but I gave up on that. And,
Yeah. That's a whole other story.
that's a whole other story. But yeah, by all means, send me an email.
Great. Well, this has been quite illuminating. This is a great addition to we have had four groups now, with the first group of the Virtual School of Internet Governance, which is well over 400 participants, which all the recordings are available, even if you're not a current student or students from the past years. They're able to access the recording. I'll send you the link as well. And again, we're launching a Spanish version of the course in September. Portuguese and French are probably later in the year, maybe even 2022. But we've also, one of our associates are working for a translation to Russian. So we're not satisfied just with an English version of this course or the weekly recordings, but as soon as I finish this, I'll add it to the YouTube channel we have, and I'll share it with the students who meet on every Monday. And you never know, some of them will get a chance to review the video and get back to you.
Well, that'd be good.
Great. Well, I appreciate your time, Fred, and all the best. And hopefully I'll see you at one of the ICANN meetings, or I guess I'll be the first face-to-face. Being on the ICANN NOMCOM, we're not going anywhere. So I think Puerto Rico in the spring of next year might be the first ICANN meeting that's face-to-face, I assume. I don't know.
We'll see.
It may happen. Okay, all the best, Fred. Thank you again.
Okay.
Thank
Sure.
you.
Bye-bye.
Bye-bye.